I'd like to introduce Professor Stuart Harrod. So Stuart Harrod is Professor of Environmental Chemistry at the University of Birmingham. Over his career, he's published over 200 papers on a wide range of issues related to environmental fate and behaviour of persistent organic pollutants, with a particular recent focus on halogenated flame retardants.
So I'm going to talk, the brief I was given to talk about human and environmental exposure to flame retardant chemicals in furniture. Obviously in 10 minutes, I can only cover a small amount of this, and I'm going to focus really on human exposure. But if we look here, as I think we've heard, and I think Jake gave a good overview, or certainly like when he was giving Richard's slides, I thought you did very well there, Jake, by the way, is that there's a wide range of chemicals that are added to both the foam and also the overlying fabrics in furniture. And these are designed to help meet the UK's furniture fire safety regulations. Many of these are ones that contain bromine or chlorine, for example. They're halogenated flame retardants, or HFRs. What I'm going to do here, for simplicity, because we only have a short period of time, is to focus on one of the currently used HFRs, and that is a chlorinated organophosphate ester known as TCIPP. Sometimes it's referred to as TCPP. Now, when I talk about this and the data that we have, because we measure concentrations of TCIPP in a variety of samples, as you'll see, what we talk about here is the sum of the 4 types, or the isomers of TCIPP. But we do measure all 4. We measure all 4 separately, but then we sum them when we report these here. Now, our published research in Ireland, and I should say we have also done work in the UK, but it isn't published yet, which is why I'm not presenting that here. In Ireland, in the Republic of Ireland, the furniture fire safety regulations are very similar to those in the UK. And what our data does there, we looked at a whole load of waste articles, and these show that TCIPP is widely used in furniture foam. And the concentrations we found ranged between just under 2 milligrams per kilogram up to 4% by weight. So 4% of the foam that we looked at in one case was TCIPP. There was an average concentration there of 0.54%, and 38 samples exceeded a concentration of 0.1%. Now that's relevant because while it doesn't apply to TCIPP at the moment, it does apply to some of the brominated flame retardants such as PBDs and hexabromocyclododecane, and where samples contain more than 0.1% or 1,000 milligrams per kilogram, they cannot be recycled. So that obviously has implications for the circular economy. And it's fair to say that we found not dissimilar findings in the UK. I'm not going to go into detail about that because these data aren't published yet, but something, that was pretty similar in the UK. So how do flame retardants escape from the products in which they're used? And we know that they escape from products, but how exactly? And I'll talk about here that we had some research a while back where we showed the 3 main ways in which they get out of products, and these apply to brominated flame retardants. They apply to like chlorinated ones such as TCIPP. And first of all, if the chemical, during use, it can evaporate or volatilize into air. And if you have that occurring, obviously it then occurs in indoor air. So we see elevated concentrations as in indoor air. We can then find that then when it gets into like cooler temperatures, it then will deposit and it will be absorbed by dust particles. both those that are suspended in the air that we might inhale, and those that are on settled dust on floors and on surfaces, like for example. We also can see that you'll get abrasion of fine particles or fibres directly to dust. So you know that if you have an old piece of furniture, you start to see that the fabric starts to fray. And if that, if you have like flame retardants present in that fabric, obviously when those fabric fibres are abraded, they will then carry the flame retardant directly into dust. And then we also see that if you have dust settling directly on the surface of a treated like a flame retardant treated article, then you will get transfer directly into the dust as it's settled on there. So it basically migrates from it's like an area which is the fabric where you have a high concentration into something that has a relatively low concentration to start off with. So the concentration gradient means that the chemicals will transfer preferentially from the fabric into the dust. And we'll also see this also then, if you have these chemicals that are present in fabrics, has been alluded to as well, dermal exposure as well. So if you're sitting on there and you might be wearing a skirt or shorts or whatever, and you also put your hands on the side, the armchair, whatever as well, you have direct like dermal uptake. And that's something, again, that I'll talk about in subsequent slides. So how does this mean that people get exposed? And we can see here, people here, there's that happy nuclear family or whatever. And we can see that, of course, as we talked about, that these chemicals will escape from the products within which they're sort of used over the lifetime of the project, which of course also has implications for their for how effective they might be over time as well. But we know that they lose these chemicals, they escape into indoor air, so we might inhale that. They escape into dust, and particularly for young children, for very young children, their personal hygiene habits aren't what we as adults would aspire to. So if you have young children, you're around them or whatever, then you'll know that they will, you have a lot more hand-to-mouth behaviour. And therefore, there's a lot of studies, there's a wealth of literature that suggests that the ingestion of dust, the unintentional ingestion of dust by young children, is a potential source of exposure to dust and any chemicals associated with that. As I said, there's the dermal uptake where you're sitting on the furniture as well, and as well, these chemicals, when they escape into indoor air, they then will and then ultimately escape into outdoor air, and they will get incorporated into the external environment. As I said as well, because TCIPP has a reasonable degree of water solubility, we've looked at drinking water as well as a potential exposure pathway. We also know that these chemicals can bioaccumulate to some extent, so we've looked at their presence in the diet. And there can also be some direct contamination via food processing, where you have TCIPP used there as well. So indoor air and dust, we measured TCIPP in indoor air in homes and in offices, and also in outdoor air in the UK. Now, the concentrations indoors significantly exceed those outdoors, and this is a classic pattern we've worked on, sort of looking at indoor contamination compared to outdoor contamination for some time. And where you see that pattern, we have far higher concentrations indoors than outdoors. That suggests that the main sources are indoors. And indeed, as we have demonstrated there, you will see it in furniture foam. But also, as well, I should point out as well, we've seen it in building insulation foam. TCIPP is really quite widely used. It would like appear in building insulation foam. I can't remember. I think it's expanded polystyrene, so XPS. We also measured it, as we measured a lot of chemicals, in floor dust and also elevated surface dust, so say like from tables as well. And the UK concentrations of TCIPP are certainly at the high end of those that we've measured and that others have reported globally. In drinking water and diet, so this is kind of the sort of more indirect exposure there. We measured TCIPP in drinking water from the UK. We detected it in over 90% of samples, at average concentrations of around about 3 and 1 nanogram per litre in tap and in bottled water, respectively. We also measured TCIPP in foodstuffs, in a fairly wide range of foodstuffs from the UK. And we compared it with what has been reported previously elsewhere in the world. The UK contamination is within the global range. As I said, we think the food contamination likely occurs, this was via review of the literature, this aspect, it likely occurs via a combination of food chain transfer, but also during like processing of foods as well. So if TCIPP is used in the food processing facilities, then yeah, there's the potential for contamination that way. Dermal exposure.
Stuart, I'm just interjecting to ask you to speed up just a tiny bit for us. We're very engaged, but we're just running tight on time. Thank you so much.
Yeah, sure. No, that's fine. Yeah. So using some human skin models, so these are in vitro models of human skin, so this is cultured human skin. We looked at human dermal uptake via contact with furniture fabrics that were contaminated with TCIPP. Now, TCIPP, to my knowledge, certainly isn't added directly to the fabrics, but of course you have the fabrics, they're in contact with the foam that contains this at several percent usually. So it doesn't just stay there. Obviously, as we know, it evaporates out, but it also contaminates the fabric. So we had some furniture fabrics that contain TCIPP, and we looked at the dermal uptake. Now, at the concentrations that were present in the two fabrics that we tested in this, 6 to 7% of that was absorbed through the skin into the bloodstream. So we know that dermal exposure occurs, and this was just over a 24-hour period. So you can get pretty high dermal exposure. The overall exposure picture, if we look at this, this is for TCIPP, and this is under a typical exposure scenario. It might vary a little bit for TCIPP depending on the individual circumstances. It will vary for other chemicals. Most of it comes from inhalation, and then there is some, a reasonable degree from dermal exposure, and some from the diet. But the other two pathways we looked at don't seem to feature too greatly. Overall exposure, this is my last slide, you'll be glad to know, Catherine, it varies substantially within the population. And the average UK adult exposure via all pathways is just under 180 nanograms per kilogram of body weight per day. Now that is well below the lowest existing reference dose or health-based limit value of 3,600 nanograms per kilogram of body weight per day. But for an individual that was exposed to the maximum indoor air concentration we recorded, the safety margin narrows to within an order of magnitude. And again, I would then point out that the recent US NTP, National Toxicology Program, evaluation of carcinogenicity of TCIPP, reports some evidence of carcinogenicity in rodents. So it may well be that those reference doses, in the same way as we've seen like for PFAS, may change, and in my experience they only ever go one way. They show things to be more harmful than we previously thought. And with that, and apologies for overrunning, that's me done.
Stuart, that was fantastic. Really, really useful and really interesting.